Okay, we're going to we continue section 35.2, the image formation by spherical mirrors. We're going to talk about convex mirrors. We talked about concave mirrors in uh, the first section. Now we're going to talk about convex spherical mirrors. And here you can see the uh, everything that we discussed. Here's the center. They don't show the radius here, but here's the center of the curvature. Here's um, the primary axis. You can see that this is the object in front of the convex mirror, and you can see that this is the one drawn perpendicular to the surface of the mirror, and this is the one drawn through the center line. And you can see that the image uh, is reduced, and it's reduced, and uh, on the backside of the mirror, so it's a virtual image. It's not a real image. Here's the focal point, um, and convex mirrors are used. You know, you see them in grocery stores. You see them in parking garages. In fact, that's the next photo I have is out of a parking garage. You can they use it so that you can see the traffic coming around the corner. Uh, the uh, it's such here that you can see the photographer. He's right in the center um, of this sphere. It's not a complete sphere, but you know that's the nature of it. You know, he's right at the center, and he's obviously much smaller than the his actual size. I use this image instead of the one that the publisher produces. I think it shows a little bit better what a convex mirror uh, is used for. But we're gonna add. Well, before we talk about adding a ray here, we just use two rays. We're gonna add a third ray, but before we do that, we're gonna on the front side of the reflecting image. Um, we're gonna talk about P and Q, uh, the object distance and the image distance being positive, the incident light and the reflected light. All of this is on the front side. Um, on the back side, you're going to have P and Q negative. Uh, no light. No light comes from that side of it. And these are the sign conventions for mirrors. This is the um, P, Q, H prime, and F, R, and M, and they're positive uh, in this column. They're negative in this column. Um, so uh, you can study that. We'll go. You can see that P is positive. Um, uh, if the object is in front of the mirror, Q is positive. If the image is in front of the mirror, the image is upright. Uh, the image H prime is upright if it's positive. The focal length F and the radius R, um, they're positive when the um, mirror is concave, and the magnification is positive if the image is upright, and they're negative when the object uh, is in back of the mirror. It's on the back side of the mirror. It's a virtual object. The negative when the image is in back of the mirror, the virtual image. The height, uh, H prime, is negative when the image is inverted, and it's negative when the focal length and uh, radius if they're negative, then the mirror is convex, and the magnification is negative when the image is inverted. So we're going to go through all three mirrors, and we have two cases with concave mirrors, where one is if you're um, outside of the focal point, and one if you're inside of the focal point. Now, if you have a magnifying uh, makeup mirror or shaving mirror, uh, if you stand back from it, you'll be inverted. If you stand away from it, if you get up closer, you become there's a point where the image is kind of blurred, but once you get past that, your face is magnified and it's upright. Wouldn't do much good if you used a magnifying mirror and your image was upside down. So, and these are the rays that you draw. You see, you can, from the object, the gray arrow, you draw a line parallel to the principal axis, and it reflects off the concave mirror, and it goes through the focal point. The green line goes from the top of the object through the focal point and back, parallel to the principal axis. And then the red line is the one from the top, perpendicular to the surface of the mirror, through this, through the center line and back. So you can see in this case where the object is on the opposite side of the focal point, that the image is inverted. Now, when the object is located between the focal point and the concave mirror surface, the image is virtual, upright, and enhanced. So here the image is real because the rays go through the image. Here they're virtual because no actual rays go through it. It's just the reflection. So if we start with the blue line, it goes to the mirror and it goes through the focal point. The green line from the center through the top of the object and then back out. And then the third one is from the center to the mirror and back out. And you can see how it magnifies the image, but it's on the opposite side. It's on the opposite side of the mirror, the back side of the mirror. Now we'll do the same for a convex mirror. You can see that the first ray, the top ray, hits and is reflected up. But notice how the image seems to come from the focal point. There's the red arrow. You can see the focal point. It continues this divergence of this ray. And here's the green image through the focal point and back away, but it hits the surface and it's reflected. And then the third one is is basically normal to the mirror, and it goes through the center of the center of curvature. So and it's always reduced. Here's like a little backup mirror, and it's concave, and so it shows everything small. So let's do a quick quiz. You wish to start a fire by reflecting sunlight from a mirror onto some paper under a pile of wood. Which would be the best choice of the type of mirror? A flat, a concave, or a convex? Well, you want to concentrate the sunbeams into one spot, so that would be a concave mirror. Okay, here, consider the image in the mirror in the figure. Based on the appearance of this image, you would conclude that the mirror is concave and the image is real. The mirror is concave and the image is virtual. The mirror is convex and the image is real. Or the mirror is convex and the image is virtual. Well, first of all, those people look pretty big compared to the people in the foreground. I mean, the real people in front of the mirror, and so that kind of rules up. It kind of rules out the convex because they would appear small. So the fact that they're upright, it leaves the fact it leaves it that it would have to be concave. Now, if it was concave and the image was real, then it would be inverted. But because they're not inverted, it only allows for B. The mirror is concave and the image is virtual. And it says, well, wait a minute, how do you know it's virtual? Well, the fact that they're not upside down means that they are inside the focal point. And there's the answer. The mirror is concave and the image is virtual. Okay, next we'll do images formed by refraction. Okay.